Hey everyone, and welcome to the makeup stream for the multiplayer shootout training with Alan and Ryan. I know we've had this canceled how many times now?
At least twice.
Yeah, due to the snow. So anyway, we're going to get into that right now. The project is available for download on the Learn tab as of yesterday, actually. So you can grab that, try to follow along. Make sure you drop your questions in the chat for the guys, and with that, I'll flip it over to y'all.
Okay, great.
All right.
So, as Chance said, yeah, here in the Learn tab, we've got the project. So go ahead and download that. Hopefully you have already. You can follow along. I think we're going to start out. Ryan's going to give a little demo, and then we'll talk about the networking portion. And then later on, I'll turn it over to me, and I'll talk about some of the sort of game designy stuff and a little bit of the artwork. So, all right, let's have at it.
Awesome. Sounds good, Alan. So we downloaded this sample earlier. I'll just open that up. And this is some of you who saw the networking stream a few months ago now. Some of this may be a little bit familiar. That was kind of a prototype version that I worked on, last year. And then Alan kind of took that, added some much more interesting gameplay, polished it up a bit. But I'm going to go over some of the new online session blueprint functionality that we added, which is still what this sample mainly demonstrates. I'll kind of walk through how all that's set up, how the UI and game instance stuff is set up.
All right, I think we're live in the back there. If you just...
Oh, yes.
There we go.
Cool. So here's the project. I'll just go ahead and run it so you guys can see. Anyone who hasn't downloaded the sample yet or saw the other stream, you can kind of get an idea of what's going on here. Actually, I should start in the main menu. Sorry about that.
Maybe also mention how you simulate multiple players, if you're going to do that, just in case anybody doesn't know.
Yeah, I'll go into that.
All right, cool.
So this is just empty level because it's just the main menu. All it has is a UMG UI. But to just simulate multiple players, open up the advanced play menu here, set number of players to 2. I'll just use 2. You can use more if you want, but I'll use 2 for ease of demonstration. So go ahead and play. We get 2 instances of the game in the editor. You see they're both sitting at the main menu right now. Just very simple default UMG menu here. So you go to the server instance, and if we play a game, you'll see he spawns in this cool little western town looking area. And then we flip over to the client. So this error is actually a bug with Play in Editor right now. If you played in standalone mode, this wouldn't happen. It's a bug, we're aware of it, and we're going to fix it. But right now you can just click OK, and then you can go ahead and find games, and this will search on the LAN for any games that are currently being hosted. And our server is hosting a game, so it shows up here with the name. This is just our randomly generated name, but if you were using Steam, for example, this would be the host's Steam username. So you can just go ahead and click on that game, and we'll join in. And you see he pops in on the other. See, there's the client there. This is kind of a cool little quick draw shootout game. I got lucky, had really good aim that time. So the goal is just to shoot the other player and get as many points as you can. And then both the server and the client can do the same thing. Right, so they're trying to shoot each other. And then there's a little in-game menu here where you can either resume or you can leave and go back to the main menu. And then you can go ahead and join again. And so there I am. Alright, so that's basically the game. I'll go ahead and go into how some of the blueprints are set up for this. How we set up hosting the match, finding the match. It all starts in the level blueprint for this main menu level. So in the begin play event for this level, we're going to go ahead and show the main menu. So this is an event on the game instance class, which kind of manages all the UI state and the overall state of the game. So I'll go ahead and open that up. There it is, my game instance. So this show main menu event is the one that was called from the level blueprint right here. So jump to that. Sorry, it's this one, show main menu event. So here we are in the game instance at the implementation of this event. As I mentioned, the game instance keeps track of the current state, which by default is set to startup. So the first time we come in, we're going to compare the state to the current state. So we're going to see if our current state is playing. It's not playing, it's startup. So we're going to skip this open level node. This is important because when you're coming back to the main menu from in-game, your state will be playing. So we want to actually open the main menu level at that point because you'll be currently in the gameplay level. But when you're just booting up for the first time, we can skip that. We go directly to the main menu state. And this transition to state is a macro that kind of eases these transitions and takes care of a bunch of the different cases here. So I'll just run through this real quickly. If the state that we want, which is main menu in this case, is not the current state, we'll go in here into this switch. You can see all the different states in the game right now. And depending on which state is the current state, we want to hide the UI associated with that state, right? So as you can see, if you are in the main menu, we want to hide the main menu widget, and so on. And that's more important later when we're transitioning between menu screens and such. So after we set the state, or after we check that, we're going to see if we have our main menu widget. So this main menu variable is just a reference to the UMG widget, which I'll show in a moment. And the first time we come in, this hasn't been created yet, so it's not going to be valid. So we'll take this branch, and we're just going to create the menu widget the first time through. We're going to set the reference to it so we can refer to it later. We're going to set the input to the set the input mode to UI only, and then we'll add it to the viewport, and that's what will actually make that main menu show up. So we'll jump over to that main menu widget so you can kind of see what that looks like. So it's just purely UMG, just a few simple buttons. Play, find games, quit. And this is the internet LAN mode switch, which I'll also get into a little bit later. Jump into the graph view. So each button is just hooked up to a simple event that also forwards to the game instance class. So it can handle, kind of in a central location, all of these state transitions. So like in this case, you hit the play button. We'll just call this event, which forwards directly to the game instance. So go ahead and take a look at that. So this host game event, like I said, is called when you click play. The first thing we're going to do is show a loading screen, which is just another UMG widget that we'll throw up there. And now we get to the create session node. So this is one of the newer Blueprint nodes that lets you interact with the online subsystems. This is what will create the online session and allow other game instances to find it on the LAN or on the online service that you're using, such as Steam, for example. Notice it is a latent node. It'll execute asynchronously because it has to, in most cases, it'll have to communicate with some online service, which involves network operation. And so we don't want to just block because that could take more time than we want to just wait for and lock up your UI. So when that completes, it'll either be successful or unsuccessful. If it's unsuccessful, we'll display an error dialog just to let you kind of know what happens, and then you can click through that and try again. If we did successfully create the session, we will still have to load the gameplay level, which is what this open level node will do. And this listen option is important here because that's what tells the engine to actually listen for connections at the lowest level from other games. So once you do that, this will actually let spawn you into that gameplay level and wait for clients to connect. Now if you click the Find Games button, that'll go into this event. It's from the widget, click Find Games. Very similar to the play button, it'll just forward the event to the game instance. Go back to that. Here's our transition node again. So now that we're transitioning from main menu to server list, the implementation here will hide the main menu widget to clear the screen for the server list. And once again, we have similar logic here. We store the server list. We store a variable with a reference to the server list widget on the game instance class, which will be invalid the first time through because we haven't created it yet. So we'll go ahead and create that, set the reference to it so we can refer to it later, add to the viewport, set the input mode, just like we did for the main menu. And so if you click this, I'll jump over to that actual widget so you can kind of see how that works. All right, so here's the UMG widget for the server list, some text boxes. This is the actual scroll box where the servers will be populated into. You can refresh the list. You can go back to the main menu. This is kind of a debug button that was helpful for me in development. It doesn't show up by default, but I left it in the sample because it might be helpful for any of you guys who download the project and are playing around with it. And you can take a look at what that does when you download the project. So if you jump over to the graph, I'll kind of show you how this works too. Could make this blueprint look a little prettier, but we didn't get to that. Sorry. Okay, so this is actually in the macro. Let me go out to the actual event graph, the main event graph. So here we have some events for the different buttons, but we'll start out looking at the construct event here. So when we construct the server list, we want to go ahead and immediately refresh the list so we can populate the list of available servers. So that is implemented in this macro here, refresh list macro, which is the one that had opened by default. So we get in here. The first thing we want to do is disable the refresh button because we don't want to allow you to refresh if you're in the middle of a refresh. We're going to set the text to searching to let you know what the status is. And we're going to make sure that you can actually see that searching text. This will be hidden once the search is completed and we actually have some servers to show. Then the next step is we want to clean out any sessions that had been found in a previous search to clear the screen for new ones. So we'll just loop through all of the previous widgets that we had created and remove them from the scroll box. So that's what that loop does. And then we'll also clear our stored array of those widgets. So this, just have to follow my ugly execution pins here. Alright, so this cast is to get the LAN mode thing. The main thing here is the find sessions node. This is the other key to the online session functionality here. This will contact the online subsystem, the underlying C++ implementation, another latent node. It'll go out on the internet or contact your service of choice and return with a list of any games that are available to join. So you have to send it a player controller that's doing the searching. You can limit the number of results that you want, and you can specify LAN mode. If this is false, then it'll assume internet mode. And this Boolean comes from that button on the main menu that lets you toggle between LAN and internet mode, which sets, when you toggle that button, it sets this variable, which is stored on the game instance. And like I said, once again, this is another latent node that can either succeed or fail. Only this time, when it succeeds, you also get an array of session result structures. So this will be a list of every game that was found on your online service. So we will take that list, and if we have at least one, well, the easy case is if there are 0 sessions, so I'll go over that first. So if you can't find any games, we just set our text, no sessions found, so you know what's going on. We enable the refresh button again so you can try your search again, and then we return. if we did find some sessions, we have some more interesting work to do. We'll hide the text because we're done searching. We're going to loop through all of the results that were found. And then we want to create a new widget and add it to that scroll box so that you can see them and click on them in the UI. So that's what this does. It'll create the server row widget, which I'll show you in a moment. Once we create each row, we store each row in this array so that we can refer to them later. If you search again, we need to be able to clean them up and remove them from that scroll box. So that's why we're storing them in an array here. And then on those widgets, we store the actual search result because we'll need that when the user actually clicks on a result. We need to get the structure that was returned so that we can tell the system which game to actually join. And then addChild actually adds the new row to the list. So I'll go ahead and jump into the server row widget. It's pretty simple. So this is, it looks a little funny. It's just a big button that's stretched to the full size of the canvas because of a quirk of UMG. I think Nick might have a fix for that. But basically, we just show the name of the server, which is usually the host's name, number of active players, total players, and this will be the text box for the ping result. If we jump into the graph, it's pretty simple. The whole thing is just a giant button. When you click on the button, we tell the game instance that you want to join a game. Let's go ahead and jump into the join event, where we get to another one of the new session nodes here. First we show the loading screen. And then yet another latent node. We pass in the search result that was stored in that widget to the join session call. And then when this is successful, you don't actually have to do anything here. It will automatically travel to the server that is hosting the session that you're joining. So it'll automatically load the server's map and put you into gameplay. So you don't have to do anything on success, but it might be useful if you want to, you're debugging and you want to print a log message or something. Make sure everything's working properly. And of course, it's also possible for the join to fail. Maybe the server shut down between the time you searched for it and the time you click join, in which case we'll just show a friendly error message and let you go back and try again. So once you do join a session, like I said, it'll load the server's map. And in this game, that map will always be this level 1. I'll show you one more thing here. I didn't change anything. So once you load in here, in the level blueprint, I have an implementation for begin play here. This was just a convenient place to change the game instance's state because you were at the serverless state, but now you're in gameplay. So once you load the map and you begin play, we're just going to set the state to playing, so the game instance can kind of keep track of what's going on here. And we'll also set input mode to the game so that you can actually control the camera and your character and everything like that. So that pretty much, I think, covers how you host and get into games. Obviously, we'll be monitoring questions, so keep them coming. And I guess I'll turn it over to Alan, and he can go over some of the more gameplay-oriented parts of the sample.
Thank you very much. Okay, let's jump back here. Gonna close some of this down and clean it up. Okay, yeah, so the original project had all the basic functionality for shooting the other players and keeping track of score and whatever, and basically I was asked to put a game on top of that. So tried a couple of different things and then happened upon this gunslinger idea. Probably the best place to start is with the gunslinger himself. So let's go ahead and open him up. All right, so yeah, maybe this is actually a good time to jump into a couple of things that we realized. When we started this project, we were on version 4.6, and some of the things that we did didn't work, or were actually, so I think some of the functionality was fixed for 4.7 and broke some of the things that we're doing in the game. So yeah, there's a couple of things that we're aware of that we're currently working on. We're going to get patched up. One of them is the hat colors. So if you, this is where we're actually setting up the dynamic material instances for the hats and setting colors. If we jump over to the event graph here, you can see this hat color section. Yeah, this is not exactly working right now, but Ryan and I are trying to come up with something to get that fixed. So once that happens, we'll go ahead and update the project, and there's probably a couple of other things that we can clean up in there as well. All right, so yeah, ultimately what's supposed to happen, let's hit play. So you can see over, let me shift windows here. See, where's this? Okay. So on the client, both of the hats are white, but if you see over in the other window there, the client players actually does have a black hat, so that's what we're going to try to get fixed up for you. But okay, a couple other things that people on the forums have mentioned already. So yes, you can shoot yourself. That was a we're going to keep that in as a feature actually, but we're going to fix up the scoring. If you notice that you draw too quickly, let's see if we can make it happen. So if you draw too quickly and shoot, you can actually hit yourself. However, it awards you a point instead of your opponent, so we'll get that tidied up as well. So yeah, you know, we're kind of walking a line of this one. It is a learning resource. It isn't like a complete game. So, you know, my tendency is to like keep working on things and try to polish them up and polish them up. But at some point, it's like, okay, let's get this out there so people can learn. And already, I know that they were waiting for it since we had started this a while back. So there, that's my preface to this little discussion. All right, so hats. Let's ignore all that. All right, where to begin? I guess we'll start with aiming here. So we have the event here for aiming. We come in and basically when we're pressing the button, we're going to call this custom event called aiming, which is right next door. And the first thing that we do is basically reset the character's aim, and we turn on aiming mode. We have a simple flag there. And then we're going to play the client aiming, which is right over here. Okay, so now immediately what happens after we've reset is we're getting a random float, and we're basically going to offset the character's arm. Just to give it a little bit of variation, sometimes you'll get lucky, sometimes you won't when you're actually playing an opponent. You might be spot on the opposing gunslinger, or maybe not. So that's how we randomize the actual position there. And then, so you're going to see a couple of different variables and pieces of functionality in this sample that actually these are not actually doing anything right now. So originally I had these variables in here to kind of tune how quickly you could aim around. They're not actually set to anything, so we can jump past there. Okay, and then as soon as we're aiming, we're going to go ahead and attach the gun mesh to the socket in the hand. So we have the gun socket there. So this is our skeletal mesh. This is the gun mesh. This is the socket that we are attaching it to. And you can see we just snap right to it. So let's go ahead and play that again. Yeah, so you can see the gun is stuck down on his leg. We hit aiming, and boom, it just jumps right in. You know, again, if this was going to be a more polished project, we'd probably take some time to clean that up and match up the animations. All right. All right, so that is aiming. And then simply when we release the aiming input, we jump over to this. Here we go, and we're just turning aiming off. Okay. All right, maybe now is also a good time to jump over to the animation blueprint so we can take a look at that. All right. Okay, let's go back to the event graph. Okay, so first thing we're doing is we're getting the pawn, and we're going to cast over to the gunslinger. And on our gunslinger blueprint, you see we have some variables here for yaw and pitch. That's basically the angle that the arm is pointing at. So we're grabbing those, and then these are duplicate variables inside of the animation blueprint that we're going to use to drive the aim offset. And we're also replicating whether or not we're aiming or shooting, because we're going to use these variables to run our state machine. Okay, so we have our initial animation here, and then we have our first rule, whether or not we're aiming. And if we are, then we play the pullback animation. These are just real simple, playing a single animation, right back out again. There's our state. And, I probably could have made the whole drawing and aiming animation one big thing, but for whatever reason when I started, I wasn't sure if I was going to have multiple pullback animations, so I split them out into separate assets. All right, just real simple rules here. Okay, actually, so we pull back, and the rule here is whether or not the animation is almost done. So as the character's arm pulls all the way back, then we're going to start transitioning forward, and that's when he's going to pick up his gun. Okay, similarly there, once that animation's almost over, we're actually going to stick our arm out. Okay, so then we go into aiming mode, which is here, and this is where the aim offset comes into play. All right, so those are those two variables that I mentioned before, yaw and pitch, and we're going to use those to drive our aim offset. So this is pretty cool. This is a particular type, a specific type of animation blend. And we can show how we put this together real quick. I'm going to go ahead and remove all of these. And so you see I have 9 points here on the compass, from upper, left, right, and center to middle, left, right, center, and lower, left, right, center. And basically, to construct one of these, you just drag them in. So this is center, center. I'm going to drag in center left and center right. And it looks a little crazy right now until we start adding some of these other animations. So here's down center. There we go. It's starting to look a little better. Down right. So we're basically populating the different points of the compass here. So that's up center. Oh, did I miss that one? That's up left. There we go. And up right. Okay, so now as I move through the graph, you can see we're updating, we're actually blending in between those 9 poses. All right, so let's scroll back up here. So again, here's the pitch and the yaw and the pitch that we're using to actually drive those rotations. And you can see we have the range here. Now, one of the decisions that I made when coming up with the design for this is I didn't want it to be particularly easy for the player to automatically, hit the enemy. So I have a pretty wide range of values here to move between, -1,000 and 1,000. That makes the moving of the arm really, really heavy. So as you're playing this, you'll see you actually have to crank the mouse a few times to get it into position. Now, if you wanted to go the other direction, you could really tighten this up. And I found, if you give it a value of like -200 to 200, if you change it up, you'll see that the slightest movement of the mouse really moves your arm quickly. So just wanted to point that out. That's one way to tune the feel of this particular game. All right. So that's how the aim offset works. And let's go back to our graph. Okay. So then the next rule is basically whether or not we're firing. So once we click the mouse button, we're going to set that is firing to true. And then we play the fire animation. So there you can see it there. Now, I cut it off pretty quick. I would probably go back and rework this a little bit in the future, but basically we just play a little bit of that animation and transition back. So you see there, it's almost like what 2/3 or something that we cut the animation off before we jump back to the aiming mode. All right, and then finally, go back to ready. See this long transition here. All this is whether or not we're aiming. So if we're not aiming, then we're going to transition back to the ready pose here. All right. So back to gunslinger. Let's look at firing since we know how that works now. Okay. And we can take a look at that shortly. All right, back to firing. So basically what we're doing here is we're getting the number of rounds left in the gun, which 6 is the default. And if we have more, great, autosave. If we have more than 0 rounds, if that's true, we're going to set shooting mode. And then we're going to spawn a projectile. So this is another custom event. Let's jump down here. And we're basically getting the location. Oh, let's jump back. See the location that we're getting. We're getting the transform of the socket that's on the gun mesh. At the very end of the gun, if you open up the static mesh, you'll see that we have a socket there. named barrel. And we're going to get that value, the location, and pump that right into the custom event along with the orientation. So that comes out over here. And that's where we're spawning the actor's projectile.
And it's worth noting here that the spawn projectile event is a run on server event, because in general you should always, when you're spawning a new actor, it's generally best to spawn them on the server so that they will replicate to all the other clients. Projectiles are important for gameplay. All the clients need to see them. So if a client is initiating the spawn, it's usually best practice is to create a run on server event and do the actual spawning of your new actor on the server.
Yeah, right. Actually, we should point out where that happens. So on the custom event here, over in the details panel, this is where you would set how you actually want it to run. All right. Okay, so then the next thing we do is we have a particle effect for the muzzle flash, nice big blue flare, and again, we're just using the transform from the socket, and we're playing that, and then we also play a sound. Okay, so back over to our graph here. Now, one thing that I found is that on the client side, when you're firing your weapon, the muzzle flash wasn't playing. So I went over and I created a new custom event. And if there's a better way to handle this, Ryan, please let me know. But basically, I am duplicating this for the client side. I'm just playing that muzzle flash.
Okay, yeah, that's a perfectly valid approach. The one exception to what I was just saying is you can certainly spawn actors on the clients if they're just for cosmetic reasons, basically, right? Like in this case, a particle effect or something that doesn't really affect gameplay. It doesn't really matter if other clients see the exact version that you're seeing on your own client. And something like a muzzle flash is a perfect example of that.
Right on. All right, very good. So what's next? We have a little bit of a delay there, and then we're going to turn off is shooting, and then we're going to subtract 1 from the number of rounds that we have, and then set that. Okay. All right, so if we're down to 0 rounds, then we're just going to branch off here real quick, and we play like a little plinky empty chamber sound, I think. A little click, click, click. All right. So yeah, this is the actual this is the actual action input that takes it, right? So if we're aiming, we say that's true, then that's where we go and jump up to that whole firing sequence. Okay, so let's see. We covered a little bit of aiming, we covered firing. What else do we need to cover? Reloading. Okay, so what happens in game if once you run out of shots, you have to stop aiming and then you can spin the mouse wheel to basically simulate spinning of the chamber and reloading each bullet. So we can take a look at that. So we have the action for reload, and as long as we're not aiming, if that's true, we're going to do the reload function, which is custom event, which is right here next door. So a little bit of a delay. So basically this is supposed to simulate from pushing the bullet into the chamber, grabbing the next one, putting it back in. That's 1/4 of a second long. So I didn't want the player to be able to just like spin the wheel and automatically fill up the cylinder there. All right, so then we just really quickly add to the number of rounds, and then once we're at 6, so our chambers are all full, set that, and then we just play a sound. There's like a little buzzer sound saying, to alert the player that, hey, you don't need to reload anymore. And okay, so if we're not full, then we play a different sound. This is sort of like a plinky coin sound, that a little bit of positive reinforcement to tell the player that they've actually reloaded. Okay. All right, so the rest of the stuff down here, all right, basically this is taking input from the mouse, left and right, up and down, and setting our pitch and yaw. All right, I left this in. As I was putting this game together, I often found the need to move my character around. I left it in. You can see here it's not actually used in game, but if you wanted to wire this back up, you could actually slide your character down with WASD. All right, and then taking damage. So yeah, we should probably talk about the projectile when you fire. So anytime you hit, the projectile is going to impart damage on the player. And Ryan, this is actually stuff that you did. So maybe, is there anything special here you want to bring up or talk about?
This is just the standard damage event that's built into the engine. We enable all the damage flags. There's like a can take damage flag on the pawn, I believe, that we enabled for these events to actually trigger. And So if once that stuff is set up, the pawn will just receive this event any damage from the engine itself. And yeah, there's a health value, I believe,
Right.
or there used to be when I made the prototype.
Yeah, so I largely kept all of this the same. So basically, here's the health, and we're subtracting from it, right? So now this is the part that I added over here on the end. So I turned it into a one-shot deal, basically. So immediately once you're hit, you're going to die, which is this event up here. And we play an animation. This is the character throwing his arms back. And then I'm going to use a timer, because with a timer, I'm going to call a new custom event called Blink. And that happens every half a second in loops. You see Blink is right next door over here. And basically what I'm doing is I'm getting that gunslinger mesh, and I'm also getting the hat and the gun. And I'm setting those to hidden. Then there's a quarter second of a delay, and then we turn them back on again, and then we play this sound. It's sort of like a warning sound, if you want to call it that. So again, let's take a look at that real quick. All right, so if I go ahead and hit this guy, way off. There we go. So that's playing of the animation and actually blinking the character, just kind of an old school death effect there. Yeah, so timers. If you haven't used timers before, really, really powerful, really useful. I use them a lot. You can get some really cool things happening. So anytime you want something to repeat for a certain amount of time, great way to do it. I'll also use it in my little projects when if I basically need the functionality of a tick, but I don't want to have the associated cost of a tick every frame, I set up a timer so that I can set the interval at, between how often I want that custom event or function to fire off. So you can use it for performance reasons as well. All right, so let's see, that was dying. Then we have a little bit of a delay. So basically this thing is going to cycle for 3 seconds. And then we're casting the player state. So this is all the scorekeeping over here. So again, this is stuff, yeah, this is all of your original code, I believe, Ryan.
Okay.
And then we respawn. Okay. So I don't know how much of this we want to go through here, but basically we're destroying the actor right away, and then we're basically going to respawn him back in. Actually, some of this was part of... So there's actually some functionality in player starts that's not yet exposed. Initially, when we started the project, the characters, the gunslingers, were randomly spawning to the 2 different player starts. Let's see if we could take a look at the level. Yeah, so you see we have our... let's look from the other direction so we don't get blinded. All right, so we have our 2 player starts. And what would happen randomly is that you'd have the player spawning in from the same location. Now, it's my understanding if you were to do player spawning through code, you can actually specify which spawn point you're going to spawn from. We understand that's not a functionality that's currently exposed in Blueprint, but it's on the list to do. So in the meantime, we had to go ahead and come up with sort of a workaround. So that's what all this good stuff does up in here. You can see we're coming through and basically splitting off on top here player 1 from player 2. And then we're repossessing them again. So yeah, we'll get that. That's probably something we're going to address moving forward. All right, so yeah, that's aiming, shooting. Oh yeah, you know what? Let's take a look at that projectile, since we were just talking about shooting. So over in Blueprints. All right. So I just simply have a static mesh, a sphere that I've stretched out. This is our collision component right here. And we have a projectile movement component on there which handles the velocity and all that good stuff, gravity, which we've turned off. I did see someone had asked a question, since we're talking about projectiles. Let's see, let me look back over here real quick. There's a question about how you combine a particle effect, the shot, with the raycast and apply damage. So yeah, I'm not actually using a raycast. That was one avenue I went down originally, but since Ryan had set up this project as a projectile, I just went ahead and piggybacked off of that stuff. So we're not actually using a raycast. We're actually just getting the orientation of that socket on the gun mesh, and that's where we're spawning the projectile. And the projectile movement component is what is sending that projectile off down the direction of the barrel. So yeah, there was a little bit of back and forth trying to get the orientation of that barrel socket the right way, but ultimately we got it zeroed out and going the right direction. So yeah, it is a, yeah, I'll call it the projectile that you see, or the particle effect, not really a particle effect, but an actual projectile is truly just being spawned out. It's not, you know, seeking some location that the ray is hitting. In other games, you know, other first-person, third-person shooters, you know, there is a little bit of guidance there, but since this isn't like really a game, this game specifically doesn't have any sort of aim assistance. You know, it's all up to the player to actually aim the arm of the gunslinger. So I chose to keep this method for spawning the projectile. All right. So, anything I missed on the player character? I think that about covers it.
I don't think so. Maybe when you draw, don't we reattach the gun model from like the holster position to the player's hand?
So yeah, on the initial play, the gun is stuck to the player's leg, but from there on out, it's basically stuck in there. So again,
Right.
this is one of those polish items where, yeah, I would probably have the guy drop the gun and, you know, reholster it. Let's see if I go ahead and shoot from the opposite direction. There we go. So let's switch back. So yeah, oh yeah, and yeah, you're right. Respawning, we do attach it back to the character's leg. But yeah, again, another thing I probably want to do, were we to polish it up a little bit, is have a whole countdown at the beginning of the game. Right now, you're basically spawned in and you're live. But you know, again, it's like that balancing act of, okay, this is a learning resource. Pretty much everyone wants this because they want to know how to do the networking and the multiplayer stuff. All the visuals
Sure.
and prettiness is like, you know, that's just sort of icing on the cake, really. A little bit beyond the scope of you know, what we set out to do with this project, but I guess that's actually a good segue. Speaking of getting beyond the scope, so I set up the lighting in the scene, sort of a dramatic, not exactly high noon, as we have sort of a setting sun thing here. I wanted to show how I went about putting this together because it's using the new distance field ambient occlusion, which is pretty neat stuff. So let me grab, you know, again, I'm going to look at this side of the screen here. I'm going to grab one of these assets, and you'll see, if I start sliding this around, you can see how those ambient occlusion shadows down there are updating in real time. That's part of that distance field ambient occlusion stuff. So, you know, I'm going to quickly show how I built this. So we'll just make a new level. I'm going to set default level. All right, so we have a few different things that work in conjunction here. You can see we have this atmosphere, which controls the amount of fog. Then we have a directional light, and we also have the sky dome. I actually went ahead and deleted the sky dome, and you'll see if we look at our directional light here, there's a setting for atmosphere sunlight. So when this is disabled, these two actors work independently of each other. I'm going to go ahead and turn that back on. Now you'll see as I rotate this around, we're actually updating the light position. So we can find the sun. Where is he? There he is. So yeah, as I change the angle of this, it's basically changing the time of day. Yeah, let's turn that off. There we go. All right, so I'm going to move that real low down to the ground. Now the sun is actually controlled. Hold on, I'm going to scoot over here so I can get a look at my settings. All right. Basically crank that up, get a nice big sun, and gonna increase the brightness. I'm gonna actually change the light color of that a little bit. That's probably a little too saturated, but you get the idea. Okay, so let's get the ambient occlusion going. So the first thing you want to do to make distance field ambient occlusion work is if we look in our editor project settings, if we go down to rendering, you'll see here generate mesh distance field. So we want to turn that on. Now I believe it may actually start out as unchecked you'll have to check it and then restart the editor, I believe, is still required. But then once you've done that, your lights will then distance field, this is the setting you want here. Use ray trace distance fields, shadows, and then we also want to drag in a skylight. So let's go ahead and put one of those in here. And I'm just going to move that up in the air. You don't have to actually do this because it's omnidirectional, but since it's a light, that seems like a logical place to find it. And yeah, let's go back to our details. And here we go. If we scroll up, you want to set that to movable. That's one of the requirements here. And again, I'm going to tune the light color a little bit. And we should probably have some objects in the scene that we can test this with. So I'll drag in a couple of crates. And maybe one of these horse stalls. How about a barrel? Okay, so then I'm just going to go ahead and build lighting. So this will just take a couple seconds. Alrighty, so you can see there some of the shadowing collecting down at the bottom of this particular actor. A little bit difficult to see, so let's go ahead and we'll increase the intensity. Let's go back here, crank this up. There we go. Let's look a little better. All right, so hopefully you can see that a little bit more. So I just basically, from here on out, once it's enabled, just went in and tuned and tweaked values until I got that really over-the-top sort of sunset look. Oh yeah, I'll show you how to do the sun rays too. This is not the best example. Let's see. So if we go to our atmosphere, which is this guy floating up top, and, or sorry, I think it's actually off of our light. Here we go, light shaft occlusion. Turn that on, and then I'm going to turn on the bloom, and that's how you get those really nice sort of God rays kicking out of there. Now, in our game, we don't actually see that, right? Because we're just looking down the streetway. But something I wanted to play with and show off. Okay. All right, yeah, so I think those are the main points I wanted to show. I guess we can go over to questions.
That's really cool. One thing I remembered, I think some people on the forums were pretty excited about the ability to shoot the hat off the other player.
Oh, yeah. Of course, the most important thing. Right.
Do you want to kind of show how? I actually haven't really looked at that
Yeah.
part of the blueprint yet, so I'm not even sure myself how you hooked all that up.
Right, okay. So, yeah, I'm really happy I actually did this because, you know, it seems to be a standard of sort of the Old West genre, right? Like blowing the guy's hat off the head. So, yeah. All right, now, first of all, I'm going to apologize for this, you know, spaghetti mess here. Like, normally, I would go back and, like, clean this up. I really like my graphs nice and neat. I make excessive use of the reroute node. But anyway, we'll try to follow this. Okay, so basically, we're in the projectile blueprint here. And every time we register a hit, we're going to play a sound, which is all this good stuff in here. And the next thing we do is we cast to the character, okay? So on the hit, we're looking at the other actor, and you see here we feed right over to this other actor that we've hit. And if we are successful, and that actor has a tag of hat, then we're going to go do some stuff. So if that's true, let's follow the chain right next door. So basically, I'm getting the velocity of the bullet. That's from the projectile movement component. And then I'm destroying the component. So like as soon as the bullet hits something, it's going to be destroyed. And I take that value, that's the velocity, out. And I'm just using a little bit of a fudge factor here, dividing it by 3. And getting, so if we can follow this, so if we follow this all the way back, what that hooks up to is, so we've hit the character. Now we're looking at the different components that we've hit. So the mesh is the hat is a static mesh component within the character. So we're going to set physics on the hat to on. And then we're getting that linear velocity, and we're going to set the linear velocity of that hat. But then we go over here, and I actually found I had to modify that a little bit. So just going back and forth, finding a bunch of these all happen to be the same, but just imparting a random velocity on XYZ, so that when you hit the hat, it's going to go flying off in some direction. And then we play a sound. So let's actually go ahead and look at the. Let's open up our other level so we have something nice to look at. That's level 1. Okay, so we will look at, let's look at our gunslinger. Yeah, so here's the component list, caps component, arrow, and so this is the actual skeletal mesh. So yeah, here's our hat mesh here. And this is the actual static mesh. You can see this is the actual physics volume here. So anytime the projectile hits that thing and registers a hit, it's going to impart those physics forces, and then since it is simulating, since we are turning physics on, that's how it bounces around. If you notice when the hat hits the ground, it kind of tumbles and bounces. So yeah, that's that was actually pretty easy to put together. And again, like I said, I'm thankful I did, because the 10 or 15 minutes that took, shooting the hat off is like the thing that everyone gets excited over. Now doing it, let's jump back to that hat again. I'll show you where you apply the tag. So if we just go ahead and search, actually, I think it's a component tag, so we have to go to the, go over on this side. So hat mesh. Now if I look for tag, there we go. So I've just added a tag for hat. I didn't get around to it, but I want to do the same thing for the gun. So basically, I would put a component tag of gun on the gun, and then over in our projectile, we would just have another branch that checks for the gun tag, and then we could do the same thing. We could send the gun flying. We could play some sort of cool hand animation, the guy shaking his hand off or whatever. So that's your homework out there for everyone that downloaded this. You can go ahead and add that. All right, so yeah, that was the hat. And if we haven't hit the hat, basically we track down here, and then this is where we handle hitting of the character, and this is where we're imparting damage. So the character's default health is 100. I wanted to make sure I killed him the first time. So I could have just set this straight up to 110, but in one of the original implementations I had like a range. So you would randomly get 1 or 2 shots before you died. So that was kind of fun. So again, this is more stuff that's kind of laying around in here, not necessary, but as a result of experimenting and putting this project together. All right. So yeah, I think that truly is it. I guess we can go over to some of the questions now. All right, I guess I'll scroll up to the top. Let's see here. All right, so this looks like a question. Just holler out, I guess, if you want to answer any of these.
Sure. So let's see. Are there any blueprint functions to do sock equals open TCP? Okay, so it looks like this question is about some of the more low-level, like BSD style socket APIs. And currently, no, those are not exposed to blueprints. You still have to drop into C++ if you want to do that kind of low-level socket manipulation. So depending on what you actually want to do, if you do need to use low-level sockets for something, you're certainly free to go for that. But just be aware that the UE4 multiplayer framework handles all that stuff for you. If you just need to, replicate actors and properties and use the framework that we have, all that stuff is wrapped up for you.
Okay. Okay, next question. Is it possible to copy Unreal characters and make animation for them / delete the animation? Absolutely. So in the original example that Ryan had put together, we're using the default mannequin guy that we use on everything, this orange dude here. And while this looks like that same character, it's actually not. The majority of our animators here use Maya for the character animations. I'm a Max guy, so I needed to get this guy out of Unreal and back into Max. And actually, I can show you how I did that. So on the skeletal mesh, you can right-click and Asset Actions Export. So I just went ahead and exported that as an FBX and then brought that into Max. So it looks like the same character, but it's actually a new version. So if you had, I guess you could take some of the characters from Unreal or some of the other projects that we have or some of the content from the marketplace and import those in. And we also have the new awesome animation retargeting tool, which is fantastic. So during the process of going out of Unreal and into Max, my skeletons didn't match up perfectly, so I was able to use that retargeting animation. You could do the exact same, or the retargeting animation function. So you could use that same feature for any other character, really, and it's like amazing how awesomely it works. It's phenomenal. So yeah, or delete animations was part of it. Can you delete animations? Yeah, absolutely. So in our animation graph, let's see, animation graph. So up here, you'll notice we have our pullback, for example. If we jump in, this is the actual animation here. So you would just import your animations as FBXs, and then in the animation graph, you could just specify which animation you wanted to use. Now, again, I was kind of in a rush when I built this. I got all the way through, finished it up, got it all working, and then I realized, well, you know, in a shootout, you're probably not going to spend all that time bringing your arm out. It works great for this example, right, because I was able to use an aim offset, but more likely, a gunslinger is going to shoot from the hip. So, yeah, I would probably go back and I guess I could keep working on this thing forever. I'd like to redo all the animations, add mustaches, you know, important stuff. But yeah, this is where you would specify which animation you're going to play. Okay.
Cool.
I think we covered this already. The next question is how to play on multiple screens like that in multiplayer, but we'll just show it off one more time in case you came into the stream late. But basically, up here from play, multiplayer options, you can specify how many screens or players you want to simulate. So this game's set up for 2, so we're just going to use 2. But you know, if we set it to 1, you'd only have 1 window. Okay.
Wouldn't using get owning player instead of get player controller 0 be a better practice in general? So I think that question came up when I was going through some of the blueprints for the menu and stuff. And yes, that is correct. That would be a better practice in general. Honestly, that was probably just an oversight on my part when I was setting that up. But yes, you all should use get owning player instead.
All right. Okay, this one I covered already. That was the particle shooting the projectile. Okay.
All right. If you are adding the session as a parameter to the server row widget, why are you also maintaining an array? Is the array being used for something else? Yes, I can show you what I'm using that for. I think all I'm using that for is so that I can remove the widgets when we refresh the when you click the refresh button in the server list. Let me go back to the widgets here. That's in the server list. Let's look at the graph. Yeah, so the first thing we do, so this is the refresh macro. The first thing we do is we loop over that array of widgets and then remove them. There might be, I think there's a remove all children, which I probably could have used instead. Maybe not. But this just seemed like the way to do it when I was first setting this up. And then we also yeah, I mean I'm sure I could just loop through all the children of the scroll box and just remove all the children because the only children are going to be excuse me, the server rows. So to be completely honest, as I was working on this, I was kind of teaching myself UMG at the same time. So some of the practices in here might be a little out of date, and I apologize for that.
All right, it looks like the next few are probably your domain.
All right, let's see. How do you pass login and options parameters in blueprints? I'm not sure exactly. I think I need some more specifics about that. What I can say is when you are opening a level on the server, let me go back to the game instance blueprint here. And the open level is from the play event, or host game event, sorry. So when you open the level as a server here, you can pass all the same options that you could on the command line. I'm just using listen here, but you can also do things like if you were typing this into the command line, or if using the open command in the console, you could set your game mode, and you could set anything else that your game has set up. Like I think in shooter game, for example, you can set the number of bots and all those kinds of options. So I'm not sure what other kind of login options
I guess you
could
could
be
always
set here, but
Yeah, I guess we could recommend just hitting the forum thread and providing some additional detail as to what it is you're looking to do, and we can
yeah,
cycle back through and try to address some of that.
yeah, that's an excellent point. How hard, easy is it to set up large numbers of lightweight clients to a server for stress testing server load? That's very easy. All you have to do is open up this play menu that we were showing earlier and set number of players. I think this will go up to 64. I'm not going to do it now because I don't want to bring down this computer. But you certainly can start as many number of clients, as you want here. I mean, maybe not over 64, but hopefully that covers your needs.
Right.
And in terms of lightweight clients, I mean, the clients are going to be as lightweight as the maps that they're loading are, I suppose. So that, that depends on how much stuff you want to put in your map, just in terms of, visual complexity and also how many actors are replicating. And you can vary those numbers and try different numbers of clients to test your servers that way. All right, I guess I'll take this next one too. How would you handle persistence across servers for like leaderboards? So traditionally for leaderboards, we would hand that responsibility off to the online service that's providing leaderboards. So Steam, for example, provides leaderboards, or if you have access to our console code, Xbox Live or PlayStation Network, will provide a leaderboard service as well. And that is one thing that's not exposed to Blueprints right now. It's something we'd like to add in the future. But we do have the leaderboard interface in the C++ online subsystem module. So if you can use C++, you can access the leaderboard interface that way. And it supports Steam and the consoles, like I mentioned. If you wanted to support persistent data like leaderboards without using a service like Steam, that's a little trickier. And you'd pretty much have to set up your own server with a database to store all the leaderboard entries, and then you'd have to, write your own communication channel between those using, sockets or HTTP or, whatever protocol you like to communicate with your server. All right, let's look at some more questions here.
Yeah, I think we're down. Yeah, that one there.
Okay, so are you able to develop your game on Steam before it's been greenlit? So to be perfectly honest, I'm not too familiar with the greenlight process myself. I know you used to need access to the Steam SDK yourself, but now we are actually providing the SDK redistributable binaries with the binary engine release. And so that should all be in the download if you download, I forgot the first version that we provided it, but definitely if you have 4.7, all the Steam, the DLLs and everything you need should be there. I believe that's the case. And in this, for example, you can use, I believe in this shootout game, we're using the Steam's example application ID. So you can use that and test your games on Steam. You should be able, we've tested Multiplayer Shootout on Steam, and it certainly hasn't been greenlit. So certainly download it, try it on Steam, and you can use that as an example and go from there.
Yeah, you basically log into Steam and it just works, right?
That's the idea.
Yeah. Cool.
All right. Is there any way to send data packets via Blueprints, or do I still need to stay in C++ to do that? So this is related to the question earlier. Yeah, we don't have any low-level like socket operations exposed to Blueprints. So you'll still need to stay in C++. I mean, obviously you can send replicated variables just like you always have been able to in Blueprints. Before, we use replicated variables heavily in this example. You can make arrays replicated, so depending on your exact needs, you might be able to just use the built-in variable replication to communicate your data that way. Can I update sessions using Blueprints? Currently, no, you cannot. The four Blueprint nodes that I that I showed earlier are the only ones that are exposed right now, but we'll be looking into expanding this functionality in the future.
All right. Yeah.
All right, so how many max simultaneous server-side projectiles are recommended? That is a really hard question to answer. It's going to depend on your game, mainly on how much other activity is happening in your game, how many other replicated actors do you have going on, how powerful your CPU is, to be honest, is part of it. Honestly, my best suggestion is to experiment. Try different numbers of projectiles, profile your game with the different numbers, and see what works for you and your particular game.
Yeah, that's going to be, I think that's going to be really application specific and
Yeah.
hardware. All right. Did you want to jump down, or I can take the replicated aiming? Should we do that?
All right. Is the aiming replicated? If so, how?
Yeah.
Yes, it is.
Okay, so I talked about that a little bit, but we can quickly go over it again because I may have glossed over a piece. But so basically, this is where we get our input over here. So we have turning, and then horizontal and vertical input basically, and we determine if we're aiming. If we are, basically we're setting these two variables, client yaw and client pitch. Now back up in aiming. See here, so this is where we're getting our, well, initially we're randomizing the client yaw, but we're basically setting yaw and pitch. These are the replicated variables. That's done there, which then over in the animation blueprint, if we go back to our, let's see, yeah, so you can see here we've duplicated, let's step all the way back to, what do I want to, event graph, this is it. So these are those variables coming in from the character blueprint, and we also have them for aiming and shooting, and then we basically duplicated those. I would probably rename these to be like anim yaw and anim pitch and anim is aiming, but basically we've duplicated those variables, and these are the ones that the animation blueprint is going to be using to update the arm of the character within that aim offset. So hopefully that answers the question. That's basically how that's done. All right. This one here.
All right, how do you do cross-platform multiplayer, for example, Fable Legends, PC, Xbox One? So for a game like that, I believe they're using the Xbox Live service, right? And so that's going to be a Microsoft-specific thing, right? It's going to depend on the platform vendor to provide that functionality. In general, Unreal supports cross-platform play, like say between Mac and Windows, and even potentially Linux. Although, maybe that hasn't had as much testing as we would have liked, or as Windows to Windows games. But it's there's certainly nothing in the engine that would prevent that at the level of your blueprints and your replicated actors and so on.
Okay. All right. How is the UMG called during reload? Oh yeah, so let's talk about that. Okay, I'm gonna have to remember myself. All right, so basically.
Oh, is this about? He's probably asking about the HUD.
Right.
Updating
yeah.
the HUD widget.
Yeah, like the little. We have those little cylinders. Yeah, actually, we'll go ahead and play that real fast. Okay, yeah. So I fire, and then you see the little dots over there emptying out, and then reloading. Yeah, so we've got what I've created an ammo widget. So if we open that up, basically we've got some, we've got a couple of different pieces of art here. We've got the actual full cylinder, I'll call it, and the empty cylinder. And let's see, let's go ahead and look at our graph. Jump over here. All right, so yeah, let's take a look at this real quick. Basically, when we construct the thing, we're setting the visibility of those cylinders and the shots within them. And then every tick, we're getting the player and the pawn, casting the gunslinger, and we're getting the number of rounds that the gunslinger has. And then from there, we have a switch. So depending on what that number is, Now, there's probably a much more clever way to handle this, but in the interest of time, I was pretty much brute forcing this. And I just basically run through and enable or disable the visibility of the shots within the cylinder. So let's see here. We'll look at 5 shots. So first thing we do is run all the way down into here. So we set shot visibility 1, and then over on the other side, we're basically turning off. This controls which ones are visible, and this controls which ones are disabled. So yeah, it's basically a big matrix of, I have 5 shots, so I'm turning off, shot number 1. I have 4 shots, I'm turning off shot 1 and 2. So yeah, that's pretty much how that works there. Again, there's probably a more clever way to do that, but whatever, it worked. Okay. For timers, do they account latency?
In terms of multiplayer game, as far as I know, they do not. I assume you're referring to just the default blueprint timers that Alan mentioned earlier. And no, I believe those are just, they're local on the current machine that's running the timer. There's nothing built in to account for latency there.
All right.
All right. Any downsides of doing network coding in blueprints as opposed to C++? How much performance impact will it have? I mean, performance is probably the main, quote, downside. I don't know offhand. Like, I can't give a specific number offhand. I mean, blueprints are in general less performant than C++ just because they have to run through the virtual machine and all that. And like I said earlier, there are some things that aren't exposed to blueprints, like you can't do direct socket operations, and even some of the session operations aren't exposed yet. So those might be reasons to stick with C++.
Okay, so we have quite a few questions. Are there any that we specifically want to call out here in the interest of time? Let's see. Is it more efficient to build your own light source or use the one provided? Again, that's difficult to say depending on your application and what it is you're trying to do. And also, can you specify a null object to have specific settings for time of day to be set on time or player controls? Absolutely, yep. And there are some good examples of that out there in the community on the forums. Some people have done similar things. So I would probably, my first stab at it would be to work with the systems that we have with the atmosphere and the directional light, and I would probably just change the orientation of that light based on whatever that parameter is that you're manipulating. So you could set a timer or get the world seconds and then constantly update the rotation of the directional light to set the time of day. That would be probably the fastest and easiest thing to do. At least to get started, yeah.
I can take that one real quick. How do I use my already written C# game server with Unreal Engine? That can be kind of tricky depending on what exactly your existing game server does. If your game server has a specific protocol over, say, one of the standard socket protocols like TCP or UDP, you can certainly in C++, create a socket and communicate with your server that way. If your C# game server already handles a gameplay state like the positions of actors and that kind of authoritative thing, that will be harder to integrate with Unreal Engine because the server in Unreal Engine already handles that kind of thing. So it kind of depends on what you want to do. But as long as you're communicating over the network with sockets, you can write code to handle your own protocol. That's no problem.
All right.
Let's scroll down a bit here.
Sure.
All right. Can you play this example through internet via IP or just in LAN? And is it possible to create a voice chat in multiplayer games with blueprints? Yes, you can play over the internet, just like any other Unreal Engine game. It's kind of built in. You can always use the open command in the console, or you can put an IP address in your command line when you're starting up the engine to connect directly to another IP address that's running a server. You just have to make sure that your firewall is not blocking the ports by default. It's port 7777. You can change that in your INI configuration. And also, like we were saying earlier, if you want to use a service like Steam, you can definitely enable Steam and then connect to any Steam games over the internet. Steam is not just limited to LAN either.
Okay, I think we have the single most important question that I need to address here. How would you go about detecting if the place got a nut shot? Would you just need to add a collision object to the character groin and use that for your hit detection? Yes. So yeah, you would you could add some sort of collision volume in whatever location you deem important, and you could tag it much like I did with the hat, and branch off and play a new animation, whatever you want to do there. So yeah, I thought that was important to address.
Probably a new sound to go with the new animation as
yeah,
well.
Yeah, probably going to need some custom sounds there.
Will this work with Steam? How can I set this up for internet play? Yes, you can set it up for Steam. The easiest way to do that is to look at the documentation that we have up on the Learn tab. There's some extra setup you have to do in your INI files to set that up. Unfortunately, that's not exposed to the editor right now, but also, again, something we'll be looking at in the future. So take a look at the documentation, and that should get you set up for Steam.
All right, I'm going to jump down. Is there a way to get data from external programs into UE4 using sockets or something similar? So if I'm not sure I'm reading that question correct, actually, on reflection. But if you're asking, can you get the sockets? I think we're talking about the actual sockets on the meshes, right?
I was thinking they were asking about network sockets.
Okay, we can answer both ways. Why don't you go ahead?
All right. So assuming sockets referring to network sockets, yes, if you use C++, you can certainly use the socket API and read data from the sockets from any external program, just like any other C++ program that you'd use BSD sockets, or you can use our socket interface as well.
Okay, yeah, it sounds like maybe you got the right answer there. Okay. All right.
We have some of the questions from the forums, or do we
yeah,
have time?
right. Yeah, I think we do. Okay.
All right. Will match state be exposed to blueprints in a future release of the engine? Yes, we would definitely like to expose that. Like I said, there are a lot of other of these online features that we'll be looking at exposing in the future, and match state is one of those things. All right. How to create a team-based multiplayer game? Please show an example. So I don't think we have time to show an example right now. But you can certainly create a team-based multiplayer game. I would start out maybe looking at the post-login event in the game mode, which we're actually doing some logic here in this sample. This will be called on the server whenever a new player joins, and you can, in that event, you can assign that player to a team, the team with at least players, or however you want to do that. You probably store their team number on your game state, or store an array of players for each team in your game state object, something like that. And then you can always just store a team number on your player state as well, and then you can just easily access that from your gameplay code. How to create a multiplayer game on internet mode. I think we kind of covered that without using Steam. So like I said, you can always connect directly to an IP address and bypass the session stuff. If you do want to, there's not really a way to use the session stuff without having a service, an underlying service like Steam or Xbox Live or whatever. So for now, internet games, you would just have to connect directly to the IP address. And then how to create a sign-up login system for the game without using Steam. That's another kind of tricky one that's a little beyond the scope of this stream, I think. But generally, a sign-up login system, once again, you would need a service, provide a server, and that stores a database with all your user accounts, and you'd have to have a protocol to communicate with that server. And that's kind of exactly how services like Steam work. So yeah, you can look into doing that. All right. What features would you like to expose next in the online subsystems? What general time frame would you like them in by? Well, like I said, there's a lot of other stuff that we need to add. There was a question about leaderboards, friends, voice, all that stuff we'd like to add. Unfortunately, I can't give a timeline right now, but we are thinking about all of that stuff.
All right.
All right.
Is that it?
I think
We're good?
we're good.
Okay. All right. Well, thank you very much for tuning in. I apologize that it took so long to get this stream to actually happen, thanks to weather and other catastrophes, but we finally got it done. And yeah, so I think there's a couple things that we'd still like to update on this project. We will try to get that happening as soon as possible, and I already spoke to Lauren about getting it all packaged up and out there again. So we'll make an announcement when the project has been updated. So we'll get those hat colors fixed right away. And yeah, I think we're good.
All right.
Okay, thanks.
All right. Thanks for tuning in.